আচ্ছা, আজকে আমরা থিসিস পেপার নিয়ে একটা আলোচনা করব। আজকের থিসিসের টপিক হচ্ছে মাইক্রোওয়েভ হিটিং অ্যাপ্লিকেশন ইন এনভায়রনমেন্টাল ইঞ্জিনিয়ারিং। Microwave heating application in environmental engineering. A review author links open overlay panel DA Jones TP নাম এখানে আছে শো মোর অ্যাড টু শেয়ার, এখানে সাইটের লিঙ্ক আছে। আচ্ছা দেখো, দি পেপার presents a review of microwave heating application. Microwave heating application in environmental engineering. A number of areas are assessed, including contaminated soil remediation, waste processing, mineral processing, and activated carbon regeneration. Conclusions are present which identify the areas of potential commercial development as contaminated soil, vertification, volatile organic compound VOC treatment and recovery, waste sludge processing, mineral or grinding, and carbon in pulp gold recovery. Reasons are detailed why other areas have not seen investment into an implementation of microwave heating technology. These includes difficulties associated with the scaling up of laboratory units to industrial capabilities and lack of fundamental data on material dielectric properties. This has meant that commercialization of microwave heating process of environmental engineering application has been slow. In fact, commercialization is only deemed viable when microwave heating offers additional process specific advantage over conventional methods of heating. ইন্ট্রোডাকশন, এখন আমরা ইন্ট্রোডাকশন নিয়ে আলোচনা করব। Since World War II, there have been major developments in use of microwave heating applications. After this time, it was realized that microwaves had the potential to provide rapid, energy efficient heating of materials. The main application of microwaves had the potential to provide rapid, energy efficient heating of materials. The main application of microwave heating today includes food processing, wood drying, plastic and rubber treating, as well as curing and preheating of ceramics. Broadly speaking, microwave radiation is the term associated with any electromagnetic radiation in the microwave frequency range of 300 MHz to 300 GHz. Domestic and industrial microwave ovens generally operate at frequency of 2.45 GHz, corresponding to a wavelength of 12.2 cm, an energy of 1.0 to 10 inverse 5 electric volt. However, not all materials can be heated rapidly by microwaves. Materials may be classified into three groups. একটা হচ্ছে কন্ডাক্টর, একটা হচ্ছে ইনসুলেটর এবং একটা হচ্ছে যে অ্যাবজর্ভার্স। The classification is illustrated in figure 1. Materials that absorb microwave radiation are called dielectrics, যেটা হচ্ছে রেডিয়েশন অ্যাবজর্ব করবে। Materials that absorb microwave radiation are called dielectrics. Thus, microwaves heating is also referred as dielectric heating. Dielectric have two important properties. One, they have very few free charge carries. When an external electric field is applied, there is very little charge carried through the material matrix. The molecules or atoms comparing the dielectrics exhibit a dipole movement. A dipole is essentially two equal and opposite charges separated by a finite distance. A dipole is essentially two equal and opposite charges separated by finite distances. An example of the Stereochemistry of covalent bond in water molecule, giving the water molecule a dipole movement. Water is the typical case of a non-symmetrical molecule. Dipoles may be neutral feature of the dielectric, or they may be induced. Distortion of the electron cloud around nonpolar molecules or atom through the presence of an external electric field induced a temporary dipole movement. This movement generates friction inside the dielectrics, and the energy is dissipated subsequently as heat. The interaction of dielectric materials with electromagnetic radiation in the microwave range results in energy absorbance. The ability of materials to absorb energy while in a microwave cavity is related to the loss tangent of the material. This depends on the relaxation time of the molecules in the material, which in turn depends on nature of functional groups and volume of molecules. Generally, the dielectric properties of a material are related to temperature, moisture content, density, and material geometry. An important characteristic of microwave heating is the phenomenon of hotspot formation, whereby regions of very high temperature from due to non-uniform heating. This thermal instability arises because of non-linear dependence of the electromagnetic and thermal properties of material on temperature. The formation of standing wave within the microwave cavity results in some region being exposed to higher energy than others. This results in an increased rate of heating in these higher energy areas due to non-linear dependence. Cavity design is an important factor in the control or the utilization of the hotspot phenomenon. Microwave energy is extremely efficient in the selective heating of materials, as no energy is wasted in bulk heating in the sample. It is clear advantage that microwave heating has over conventional method, bulk heating in furnaces. Microwave heating process are currently undergoing investigation for application in number of fields where the advantages of microwave energy may lead to significant saving in energy consumption, process time, and environmental remediation. Compared with conventional heating techniques, microwave heating has the following additional advantage. Ontario Hydro Technology website also higher heating rates, no direct contact between the heating source and the heated material, যেহেতু এটা রেডিয়েশনের মাধ্যমে হবে. Selective heating may be achieved, greater control of the heating or dry processing, reduced equipment size and waste. The principal areas of study reviewed in this paper are mineral processing and waste treatment, contaminated soil remediation, recycling or rubber, activated carbon applications, and treatment of volatile organic compound (VOC). Section snippets: contaminated soil remediation. Electrical heating along the radio frequency RF heating was used in the 1970s for the recovery of bitumen from tar sand deposits. Low frequency radiation has also been used to enhance soil vapor extraction (SVE) of contaminated soil. Microwave assisted soil remediation applied to the in situ remediation of sites contaminated with volatile compounds. Microwave heating possesses many potential advantages in the treatment of vast array of waste. The important characteristics are summarized below. Significance: waste column reduction, rapid heating, high temperature capability, selective heating, enhanced chemical reactivity, ability to treat waste in situ, treatment or immobilization of hazardous component to meet regulatory requirements for storage, transportation or disposal, rapid and flexible process, mineral processing with microwave energy. Various applications of microwave being heating have been processed for the processing of mineral. One particular area of the reduction of grinding costs through a phenomenon which known as thermally assisted comminution. Thermally assisted comminution is the heating and quenching of ores to reduce lattice strain, therefore reducing grinding cost. The lattice state কমা দেয়, ফলে grinding cost কমে যায়. Conventional thermally assisted liberation of mineral required large heat input and overall energy balance is unfavorable. Conclusions: in the preparation of the article, a significant number of references have been examined. Many have stated that the effective adoption of microwave heating would possibly reduce process time and reduce the required process energy consumption. Apart from highly specialized application, microwave heating application have seen little commercialization in the field of environment engineering. This is for several reasons. Firstly, little fundamental data exists regarding the dielectrics. Acknowledgements: the author would like to thank the University of Nottingham for funding this research. Reference 1 reference দেওয়া আছে, তো জন্য রেফারেন্স ইউজ করা হয়েছে এখানে। তো এটাই হচ্ছে মোটামুটি আমাদের যেই একটা রিসার্চ পেপার, সেটা তো রিসার্চ পেপারের মধ্যে আমাদের যেই বেসিক জিনিসগুলো আছে সেটা হচ্ছে, প্রথমে আমাদের ইন্ট্রোডাকশন থাকবে। ইন্ট্রোডাকশনের পরে আমরা দেখব হচ্ছে mineral processing with microwave energy, conclusion, acknowledgements, reference, section snippet. আমরা পরবর্তী যেই আরেকটা সেটার প্রতি আমরা এখন দেখবো, এটা আরেকটা রিসার্চ পেপার, সেটা হচ্ছে বলছে যে মাইক্রোওয়েভ এনার্জি ফর মিনারেল ট্রিটমেন্ট প্রসেস, এ ব্রিফ রিভিউ, অথর লিঙ্ক ওপেন ইন ওভারলে সাইট থেকে আমরা চাইলে ঘুরে আসতে পারি এখান থেকে। শুরু করি আমরা এখন। এটা হচ্ছে ইন্ট্রোডাকশন। এখানে টেক এ ব্রেক, 2 মিনিটের ব্রেক নিয়ে আবার শুরু করবো আমরা। ওকে, we are back. এখন আমরা দেখবো যে মাইক্রোওয়েভ এনার্জি ইজ এ non-ionic electromagnetic radiation with frequencies in the range of 300 MHz to 300 GHz. Microwave frequencies include this three band of ultra high frequency, the super high frequency, and the extremely high frequency. Microwave have extensive application in the field of communication. However, the Federal Communication Commission (FCC) has allocated certain frequencies for industrial, scientific, medical, and instrumentation (ISMI) applications. Table 1 shows some of the ISMI frequencies. Currently, 2450 MHz is the most commonly utilized frequencies for home microwave, which was invented by Parley L. Spencer almost 50 years ago. Microwave power in industry. It is reported that annual sales of microwave oven in USA is 1.5 to 2.0 billion dollars. Microwaves can be reflected from a sample mirror, such as metallic sheet, are refracted at a dielectric interface, can be focused by parabolic reflectors or horn antennas. Microwave energy is divided from electrical energy with a conservation frequency of approximately 50% for 2450 MHz and 85% of 950 MHz. Microwaves have longer wavelengths and lower available energy quanta than other forms of electromagnetic energy such as visible, ultraviolet, and infrared light. Microwave heating is unique and offers a number of advantages over conventional heating, such as non-contact heating, energy transfer, non-heat transfer, rapid heating, material selective heating, volumetric heating, quick start up and stopping. Heating starts from interior of the material body. Higher level of safety and automation. Basic concepts of microwave heating. Microwaves cause molecular motion by migration of ionic species and or rotation of dipolar species. Microwave heating a material depends to a great extent on its dissipation factor, which is the ratio of dielectric loss or loss factor to dielectric constant of the material. The dielectric constant is a measure of the ability of the material to retard microwave energy as it passes through. The loss factor is a measure of the ability of material to dissipate the energy. In other words, basic heating system. The microwave heating system is made up of four basic components: power supply, magnetron, applicator. Power supply, magnetron, applicator for the heating of the target material, and waveguide for transporting microwave from generator to the applicator. Figure 2 shows simplistic diagram of the microwave heating system. Temperature measurement. Continuous temperature measurement during microwave irradiation is a major problem. Luxton fluoroptic or aquafiber can be employed to measure temperature up to 400 degrees Celsius but are too fragile for most industrial application. An optical polymer and thermocouple can be employed to measure higher temperature. Optical pyrometers such as thermovision infrared camera only record surface temperature, which is invariably much lower than interior sample temperature when thermocouple. Microwave exposure standards. Human tissue and body fluid are highly receptive to microwave radiation and must be protected against excessive exposure. For a number of years, an upper exposure standard of 10 megawatt per centimeter or 100 watt per meter square was used for personal working in a microwave environment. Currently, microwave leakage at a 50 centimeter from the outer surface of the oven must not exceed 1 megawatt per centimeter square with a test load in the oven and 5 megawatt per centimeter square without test load. Microwave heating of mineral and inorganic products. Early as 1967, Ford and Perry applied microwave energy to the heating of a number of reagent grade metal oxides and sulfides. Microwaves of 2450 MHz were applied to the heating of a 10 gram to 200 gram power sample per batch. Able to show the test results, the author concluded that dark colored compounds heated rapidly to high temperature and heating rates of dark colored compounds were much higher than those of light colored compounds. Further, microwave assisted or grinding. Demonstrated the rapid heating of ore containing microwave energy absorbing mineral in a non-absorbing matrix generated thermal stress. This thermal stress caused microfraction along the mineral grain boundaries. As a result, such an ore sample becomes more amenable to grinding. According to these authors, the grinding operation consumes 50 to 70% of the energy used. Mineral processing operation against the energy. Microwave assisted carbothermic reduction of metal oxide. ওকে, এখন আমরা একটু 2 মিনিটের ব্রেক নিয়ে আবার শুরু করবো একটু পরে। Alright, we're back again. The vast majority of heavy metals, oxides, and carbons, as charcoal or coke, responds to microwave heating. Therefore, the microwave assisted carbothermic reduction of metal oxides is possible. If the metal oxide is low, lossy, is poor receptor or microwave energy, then added carbon plays the role of microwave heating accelerator. Various researchers have demonstrated that iron oxides mixed with carbon could be reduced to metallic iron. Microwave assisted drying and anhydration. Microwave energy is finding increasing application to the drying of various kinds of materials and productions such as agricultural, chemical, food products, textile, paper, lumber, many more. Generally, drying refers to removal of physically absorbed solvents such as water, acid, high vapor pressure organic substance, alcohol, acetone, ether, halogenated hydrocarbons, aromatic, etc. Anhydration refers to the removal of microwave assisted mineral leaching. Analytical chemists have used microwave heating devices routinely for the dissolution of metals, minerals, and various chemical products in chemical analysis. As mentioned earlier, microwave heating is material specifics offers a faster heating rate and consequently a faster dissolution rate than conventional heating. The principle of the dissolution of analytical samples have been applied to the leaching of various minerals contained in microwave assisted roasting and smelting of sulfate concrete. Reported test result from roasting a nickel bearing with microwave energy under controlled supply of oxygen. Over 90% of the sulfur in the pyrrhotite was converted to elemental sulfur, and iron and nickel were oxidized into ferrous oxide, nickel oxide, nickel ferrous oxide, and nickel sulfur oxide. Gold is considered to be refractory when it cannot be easily recovered by alkaline cylinder leaching. The vast majority of refractory gold occurs in sulfuric minerals such as pyrite, arsenopyrite, and pyrite generally refers gold concentrate or one pre-treated by roasting, oxygen pressure leaching, bacteria leaching to render the amenable gold recovery by alkaline cylinder leaching. Microwave assisted setup spent carbon regeneration. Currently, more and more gold and ore processing industries are using activated carbon CIP, CIL. The carbon is regenerated after each cycle of adsorption and desorption of gold cyano complex. Usually the spent carbon is regenerated by washing with mineral acid followed by heating at high temperature in an extremely heated rotating kiln. It has already been mentioned in the review that carbon microwave assisted waste management processing industrial invariable generate waste material. Mine milling industries are no exception. To um, mitigate the danger present by the constituent of the waste, technologies are being investigated to minimize waste generated, to provide safe handling, transportation, storage, reduction, removal, or disposal of hazardous waste. Currently, microwave energy is showing considerable potential in the management of vast array gaseous, liquid, and soil waste. So this is for today.